Hello, Assalamualaikum. My name is Nuraina Biha binti Muakhir. I'm from Group 10 and I'm studying in UiTM Tapa. So this year is my first sem. In this video, I'm going to talk about orbital diagram and how to draw them and how to place the electron within each orbital. So, the important things we must know what is Hund's rule. Hund's rule, the most stable arrangement of electron is that with the most unpaired electron all with the same spin. So for example, let's start with nitrogen. So nitrogen has an atomic number of 7. The first thing we need to identify the electron configuration of nitrogen, which is 1s2, 2s2, and 2p3. So once you have the ground state of electron configuration, then you can draw the orbital diagrams. So D is 1s energy level, D is 2s energy level, and D is 2p. We always have 3 orbitals. 1, 2, 3. So what we want to do is we want to fill up each orbital from the bottom all the way to the top. So the first orbital has 2 electrons and we need to put upper side spins. Now once we get to the 2p orbital, each of these orbitals they have the same energy. And so as a result, they know as degenerate orbital. Now, when we fill in degenerate orbitals, you need to fill them up one at a time with parallel spins. So, when you put the first arrow in the first orbital, you should not put the second one in the same orbital. Rather, the next one has to go in the next orbital but with parallel spins. So, if the spin is facing upward in this orbital, then the second spin should be parallel to it, should be facing upward as well. And the third spin will be doing the same. So, nitrogen has 3 unpaired electrons. So, we move to the next example, which is sulfur. Sulfur has an atomic number of 16. The first thing, we need to identify the electron configuration of sulfur, which is 1s2, 2s2, 2p6, 3s2, and 3p4. So once we have the ground state electron configuration, then we can draw the orbital diagram. So D is 1s energy level, D is 2s energy level, D is 2p energy level, which is P always have 3 orbitals, 1, 2, 3, and D is 3s energy level, and D is 3p energy level. So what we want to do is we want to fill each orbital from the bottom all the way to the top. So the first orbital has 2 electrons and we need to put opposite spin, same with 2s. Now when we get to the 2p orbital, each of these orbitals they have the same energy, and so as a result they know as degenerate orbitals. Now when we fill in degenerate orbital, we need to fill them up one at a time with parallel spins. So once you put the first arrow in this orbital, we should not put the second one in the same orbital. Rather, the next one has to go in the next orbital but with parallel spin. So, if the spin is facing upward like this, in this orbital, then the second spin should be parallel to it, should be facing upward as well. And the third spin will be doing the same, like this. So we move to 3s, which is only has 2 electrons. And we need to put opposite spin. And also 3p4. So let's move to the last example, which is vanadium. Vanadium has an atomic number of 23. So the first thing, we need to identify the electron configuration of vanadium, which is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d3. Same like we do before this, we must fill each orbital from the bottom all the way to the top. So the first orbital has 2 electrons, and we need to put opposite spins like this. Same with 2s2. Okay, so like we know, 2p6 is the generate orbital, so we need to fill them up one at a time with parallel spins, like before this. Okay, we move to 3s2, have 2 electrons only, and 3p6 like 2p6, same, which is known as degenerate orbitals. And 4s2 have 2 electrons only. So 3d3, we know D always have 5 orbitals. So we need to put the first arrow in the first orbital, and then we should not put the second one in the same orbital, like this. So rather, the next one has to go in the next orbital but with parallel spins. Okay, so if the spin is facing upward in this orbital, then the second spin should be parallel to it, should be facing upward as well. And the third spin will be doing the same thing, like this lah. Okay, so this is 3d3 because only have 3 electrons, but D always have 5 orbitals, 1, 2, 3, 4, 5. So the result like this for 3d3. Okay, so for conclusion, we know how to draw the orbital diagram. First is we must always remember the orbital diagram, which is S always have one orbital diagram, and P always have 3 orbital diagram, and D always have 5 orbital diagram, and the last one, F always have 7 diagrams. So the second thing that we must remind, we must fill each orbital diagram by using Hans rules. Okay, so good luck and thank you.